Alright, so in this video we will be learning about the second method. And the second method, it is very similar to the false position method, but in the false position method, as in every iteration we take out the root of the answer, but in this one we will not be taking out the root, as there is no bracketing system in this one. So let's move on with the code, and it is very similar to it, but that is the main difference. So firstly, here I have defined the second method, and the parameters here to help you understand better are func, which is the function for which the root is to be found, and x0 x1, these are the initial guesses, or also you can call them the lower or upper bound. And TOL, tolerance, this is the desired accuracy, and you can totally kind of alter it if you want, and it just, if you increase the number it will just be more accurate, and if you keep it low then it won't be as accurate, so it is totally up to the user. And here you can alter it. My bad, I've actually put the value to exponent minus 6, and you could put it to anything that you want. And here the user iterations, it is the number of iterations that the it must perform, the maximum number of iterations. So for example, if you input that I want to do 100 iterations, but the method actually stops at about 10 iterations and it reaches this accuracy, so it will just stop there, and it will give you the number of iterations that it actually went through. And what the results of this code will be, that the root, it will be the approximate root of the function, and the iterations, that will be the number of iterations that were actually performed to get that accuracy. And let's get into the code. So first we will be using a loop for iterations, and it enters a loop that iterates until the specified number of iterations, which is the user iterations, it is reached. And the user iteration, that it is the one that we'll be giving the input of, and it calculates the function values at x0 and x1, and the function f underscore x1 is equals to function x1, and the same for x0. And it checks the denominator values over here, and the fx1 is fx1 and fx0 is smaller than the tolerance, so it raises a value error, since the denominator in the second method formula approaches 0. So you will just, if they're less than the tolerance, so you will just get this error, and then the user will have to reconsider their input. So moving on to here, this is the formula for the second method. Again, there are multiple formulas for each method, so it is totally up to the user how comfortable they are with each formula, and it is totally a personal choice. Now moving on over here. Now over here we are checking if the root has been found within the specified tolerance. So here what we do is checks if the absolute value of the function at the current approximation, which is x2, as I have written here, which is x2, is less than the specified tolerance. And if that is the case, it will return the approximate root and the number of iterations that were performed. And if that is not the case, then it will just give this value error, that the second method that did not converge within the iterations that were given by the user. And over here what we have is the user input, and here's again the same example, the same example that I've used. And you could also change this according to your question. If you have a question that has another equation, you can just erase this and put that equation over here, and it will work the same way as it does for this one. And again, moving on to the tolerance, over here I have used this number, but it's totally a personal preference, and the higher the number is, the more accurate the result will be, and it's totally what you want. It is not a definite value. So moving on to the input that we will be taking from the user, the x0, which is the the lower bound, it will ask the user to enter the first guess, and x1, which is the higher bound, will ask the user for the second guess, and this will ask the user for the number of iterations, the maximum number of iterations they would like. And after that, this function will just compute everything, all of the parameters in this. As you can see, the example function x0 x1 tolerance, it will take everything into mind and apply it over here, and in the end the approximate root will be printed over here, and the number of iterations that took to print that approximate root will also be given over here. And in the last video for the false position method, I'm sorry that I was not able to give you the result, but I was not able to run the program for you, and this time I will make sure that I do it. So just to give you guys an example, let's run it, and let's put a lower bound of, let's say, let's put it as 3, and let's put the higher bound as 6. Alright, and let's say the maximum number of iterations I want to perform. And as this is a computer, so you can put anything and it will do it instantly. So let's just put, alright, let's just put 2 and see what it does. And it will probably give an error. So you can see as it gives an error because the tolerance, the accuracy was not reached in that. So let's try it again. And let's do 3, 6, and let's do about 50 iteration and see if it is completed in 50. Alright, so the number of iteration it took to reach that tolerance was 7, and this is the most approximate root that it could reach in 7 iterations. And this was the second method, and thank you for watching, and I hope